Welcome to the debate. Today we're shifting gears a bit. We're moving from high theory to, well, high volume production. Specifically, we're diving into the really quite sophisticated, multi-stage industrial process that turns, simple raw ingredients into finished sausage based on our source material. It's a fascinating mix of culinary tradition and pure industrial physics.
It really is. We're talking about production lines moving at incredible speeds, forming what, a handful of sausages every second? The scale alone means the manufacturing tolerances have to be incredibly tight, even though the starting materials, the meat and fat, are naturally variable.
Right, which sets up our central question for today. When you're making sausage at this kind of industrial speed, is the final quality, and crucially, the consistency, primarily down to the technological precision? The machines, the temperature controls, speeds, pressures. Or is it really dictated by the rigorous, foundational handling and the quality of those core biological ingredients, the meats, the fat, the water content, even the order you mix things in?
And I'll be taking the position that fundamentally, it's that ingredient quality and the disciplined, foundational handling steps that are non-negotiable.
I think the technology, impressive as it is, mostly just protects the integrity that's already been established by the ingredient science.
Okay. And I'm going to argue that the sheer scale creates extreme physical challenges, heat, pressure, speed, and that overcoming these requires such technological precision that this becomes the paramount factor. It's what determines success, consistency, and prevents, frankly, catastrophic failures. So my core argument really stems from the physical reality of this process. The speed and scale demand technology to manage immense kinetic and thermal forces. Success really hinges on precise, moment-to-moment control. Let's take the cutter. The source calls it the heart of the process. The blades are spinning at up to 5,000 RPM. Now, that intense speed generates huge amounts of heat through friction, heat that would absolutely wreck the product, melt the fat right out if it wasn't actively countered. So the need for technology here isn't just about making things faster. It's about basic survival of the bat.
I understand focusing on that immediate physical challenge of the heat, but let me offer a slightly different take, maybe more from the food chemistry angle. I'd argue that high-speed tech is basically useless, maybe even destructive, if your starting material doesn't meet fundamental requirements. Quality control has to start right at the beginning. The source material is clear about this rigorous screening. They reject incoming meat blocks immediately if the water content is too high.
And why is that initial rejection so critical from your perspective?
Well, because excess water completely undermines the final texture and the flavor. You get a sort of gummy mouthfeel, poor binding. It's a foundational flaw you just can't fix later with speed or fancy cooling. So that ingredient quality check is the absolute first and I'd say most crucial gate. Technology can't magically improve meat that's already compromised at a, molecular level. It just processes a bad input faster. Okay, but I think the most dramatic and arguably most costly failures happen during the high-tech stages, needing that high-precision intervention. Take the stuffing stage. You need precise, coordinated high pressure to fill the casings evenly. The source is very explicit here. A bit too much pressure, the casing explodes. That's immediate total product loss plus downtime for cleanup. Too little pressure? You get deformed sausages, air pockets, so that specific moment, preventing explosions and ensuring a standard shape, that feels like a purely technical control point that dictates success or failure on a massive scale. That's a fair point about the stuffing pressure being a technological challenge, though I might frame it a bit differently. Isn't the engineering challenge there simply managing the physical state of the emulsion that was created earlier and what dictates the quality of that emulsion?
It goes back to the mixing sequence. The process insists that salt goes in first. Why? Specifically to extract myofibrillar proteins, myosin, mainly, which act as the natural glue, the emulsifier, binding the water, fat, and lean meat. If you mess up that foundational chemical step, the mixture won't stabilize properly. Then your high-pressure stuffing stage is likely to fail or give you a weak, crumbly sausage, no matter how precise your pressure valve is. I certainly agree the underlying chemistry is vital, but it's the technology that translates that chemistry into a safe, consistent, shelf-stable product people actually buy. Think about the final setting, the cooking stage. You heat it maybe a water bath, maybe a steam boiler, just enough to denature and set those proteins.
And why is that specific stage so critical?
Because it's incredibly high stakes. It's an extremely narrow temperature window. Too low, the product's unsafe, perishable. Too high, you destroy that delicate fat-water-protein balance. The fat renders out, the sausage shrinks, or bursts, or gets that awful spongy texture. Success or failure, the difference between a perfect sausage and a ruined batch, comes down entirely to managing that thermozone with like millisecond precision engineering. For me, technology is the absolute primary determinant right there.
I see it more as technology acting as the guardian of the process. Yes, but what it's guarding is the integrity established by the foundational ingredient chemistry. Okay, that distinction leads us nicely to our first real point of contention. Is it catastrophic failure versus foundational defect? I'm arguing that those precision stages, emulsification in the cutter, thermal setting during cooking, represent the moments of highest risk for catastrophic, large-scale loss of product.
Right. Whereas I come at it from a different angle. I'm saying those initial foundational flaws, like using meat with the wrong fat ratio or that high water content we talked about, they lead to an irreversible defect. Something wrong with the flavor, the juiciness, the basic structure. Technology cannot fix a fundamental ingredient flaw. It can only process it poorly. The potential for a great taste profile is ruined before the cutter even spins up. But I'm not entirely convinced that a compromised flavor profile, while obviously not ideal, represents the immediate defining factor between success and failure in high-volume industrial terms. Look, an ingredient deficiency might lead to a mediocre product, maybe sold at a lower margin, right? But a technological failure means no product, zero, an immediate total financial write-off. If the fat melts out during cutting because, say, the shaved ice delivery system malfunctions, or if hundreds of sausages explode during setting because the boiler temp spikes, that's an instantaneous volume-destroying disaster and is prevented only by constant real-time technological monitoring and intervention.
I absolutely acknowledge the financial hit of an immediate tech failure. But isn't quality control designed precisely to mitigate risks inherent in the ingredient itself? You highlighted technology saving the day, but remember, that initial screening rejects meat blocks specifically because the downstream technology cannot reliably handle that foundational instability, like too much water. That first step, based purely on analyzing fat and water content, prevents defects that would make all the subsequent high-tech steps basically, well, a waste of energy, processing substandard stuff. That focus on input quality is definitely critical, I agree. But it leads us straight back to the source of the main challenge technology has to solve, the sheer energy involved, which brings us to our second point, the cutter's speed. That machine spinning at 5,000 RPM creates a stable emulsion rapidly.
That texture, that stability, which is really the defining quality of this kind of sausage, seems to me purely a result of technological power.
See, I just don't quite buy that the technology is the primary driver of quality there. It feels more like the primary driver of speed and scale. Yes, the cutter's essential for volume, but the whole reason you need those clever technological solutions like adding shaved ice is to fight the side effect of that speed. The machine is essentially battling the inherent biological tendency of the fat and protein to separate under heat generated by its own action. But surely, without the extreme technological speed, you physically cannot achieve the tiny particle size, the thorough fat dispersion needed for the stable emulsion consumers expect. The source material mentions the protein film needing to encapsulate the fat globules. That only happens reliably at scale because of the immense shear forces from those 5,000 RPM blades. It's that technological intensity producing the superior, stable texture.
I agree stability is crucial, but again, I see the tech as serving the biological requirement. I have to go back to the mixing order. The biology dictates the tech needs. You must add salt first to extract those binding proteins. If the myosin isn't properly liberated and available, the fat globules won't get encapsulated effectively, no matter how fast the cutter spins. The technology acts on the biological structure, Sure, but that structure is built by disciplined, foundational handling first.
And furthermore, the mechanism used to fight the heat, the ice addition, is itself a marvel of technological precision. It's not just dumping ice cubes in, it's a constant, controlled injection of shaved ice. That needs a high-precision delivery system, adjusting the coolant rate based on real-time friction sensing. That level of sophistication is the difference between a stable emulsion and, a separated soup. That fine-tuning is technology driving success against the biological clock of spoilage.
That's a compelling technical point, yes. But the ultimate aim is still preserving the ingredient's natural structure from the heat generated by the process. Okay, let's shift to the final critical stage, smoking and preservation. To me, this stage really highlights the necessity of technological control over what was traditionally an art. The source describes these high-precision smoking chambers, managing temperature, smoke density, humidity, all with digital accuracy.
That's a very strong argument for achieving uniformity, I'll grant you. But have you considered the fundamental nature of what's being achieved there? The source explicitly calls smoke an ancient preservative. It draws out moisture, inhibits germs. This is a foundational chemical interaction between the smoke compounds and the meat. It's not something technology invented. Technology just controls the application.
The chemistry might be ancient, sure, but the reliable, uniform application across thousands of units per hour, that's entirely a product of modern tech. Getting consistent flavor, color, and preservation across a huge batch relies completely on that chamber holding, say, precisely 90% humidity at 150 degrees Fahrenheit for exactly 48 minutes. If the timing's off, too short, weak flavor. Too long, acrid, overpowering. That complex governance over the final sensory result and safety feels purely technological to me.
I agree the consistency comes from the technology, but the quality of the flavor itself, that's rooted in the ingredient science of the smoke source. The material specifies clean-burning beechwood as preferred. Why? Because its combustion yields the most desirable phenolic compounds for flavor and preservation. The tech chamber just provides the optimal environment for that interaction. If you put poor quality wood chips in the most precise chamber ever built, you'll get a consistently poor-tasting product. The success originates with the quality of the wood and its interaction with the quality of the meat, not just the temperature sensor.
But if the humidity control fails, or the smoke density sensor is off by 10%, that high-quality beechwood is completely wasted, isn't it? It either imparts a weak flavor or a bitter, uneven one. Technology eliminates the variability that plagued traditional smoking, ensuring the potential excellence of the ingredient is perfectly realized for the consumer every single time. In industrial production, that consistency is the quality metric. Consistency is absolutely vital, yes, but consistency in mediocrity isn't the goal. The entire technological infrastructure from the ice shaver to the stuffer valves seems built around protecting the intrinsic value established right at the start, selecting the right beef cuts, rejecting high-water meat, correctly extracting proteins with salt first. This whole discussion really underscores the incredible complexity of modern food production. But to summarize my view, making the leap from highly variable raw ingredients to a standardized, safe, perfect product and doing it at incredible speed fundamentally depends on technological mastery over physics, friction, temperature, pressure. These controls prevent catastrophic failure and ensure uniformity, which is the definition of quality in high-volume manufacturing.
And I'd summarize my position by agreeing that technological precision is the essential guardian, ensuring safety and consistency at scale. However, the ultimate intrinsic quality, the taste, the color, the texture, the fundamental structural integrity that's inextricably linked to rigorous selection, preparation, and preservation of the core biological ingredients, starting from the very first step. Technology protects quality, ingredient science and foundational handling define it.
Well, it's certainly clear that the modern sausage factory is a place where the line between ingredient science and process technology is incredibly fine. You really need excellence in both simultaneously to get a product that's safe, consistent, and hopefully delicious.
Indeed. It's a long, technically demanding journey from, the farm commodity to the finished item on the shelf. It perhaps invites us all to appreciate the complexity behind that seemingly simple sausage.